Hello everyone, I am Soumyashree Senapati, Assistant Professor, Vedang Institute of Technology. In this class, we will discuss how to determine unit weight of soil. So, we have already discussed how to determine specific gravity, water content and the index properties of soil. So, to determine unit weight of soil, there are various field methods. Okay. So, these first those methods are like core cutter method, water displacement method, submerged mass density method. The most important is your sand replacement method. Okay, these are some field methods. We can only conduct these methods in field. So, first going to core cutter method. So, basically core cutter method is a field method. We can see the diagram first to know how the process of core cutter method going on. Like here is your total core cutter. Okay, here is the container and cutter. So, we need to first specify a place, and first we will specify a place and we just level it. Okay, so then what, then we will put this container inside this place. Okay, so inside this soil we will place the core cutter. So before putting the core cutter inside the soil, we need to verify the soil, that the soil should not be gravel or coarse aggregate. It should be clay soil or silty soil. Okay, so here is your container, here this is your dolly. So we put this container inside the leveled soil. Okay, so after we insert the core cutter, we will put the dolly here. Okay, so by using this, here is your rammer. So here the cutter size is mentioned, like the total depth of core cutter will be what? It will be nearly 13 centimeter, right? It will be nearly 13 or 14 centimeter. Next, the depth will be 105 mm. Okay, so about rammer, these to these, only these to these will be 75 mm, and the total height of rammer will be 900 mm, that will be 90 centimeter. Okay, and this whole diameter will be 140 mm, right? So here it about your dolly, that the depth, inside depth will be 100 mm and the outside will be 115 mm, right? So what is the procedure? After inserting the cutter inside the soil level, we will put the dolly here. Then by using rammer, we will put the container totally inside the soil level. Okay, so what next? After putting the soil, after putting the core cutter inside the soil, we will take the soil with container. Okay, so we will take that as W2, container plus soil. Okay, so after replacing the soil from container, we will take the weight of container. Okay, so we will take that as W1. Now we have both W1 and W2 right here. Weight of core with soil sample is W2 and empty core will be W1. Okay, so what it says, we have the weight here. So as we know that we are calculating our unit weight, right? We are calculating unit weight of soil. So unit weight is denoted by gamma, right? So, what is the formula for gamma? We know gamma will be weight upon volume. So, as we are determining what? Unit weight of soil. So, for unit weight of soil, we will need weight of soil and volume of soil, right? So, here we have W2 as container plus soil and W1 as container. So, if we subtract W2 and W1, so we will get the weight of soil, right? Here W2 minus W1, and the volume is already given. Core cutter of known volume, that is 1000 cc, okay, is pushed into the ground and the core containing soil is taken out from the ground, right? So the volume of core cutter is already given, okay, so that we will take as volume. So here we have gamma B, that will be gamma bulk, that is W upon V, right? So we get the value for gamma bulk. So what will be gamma dry? Your gamma dry will be gamma bulk upon 1 plus omega, okay, that will be your water content of soil, right? So we have already learned what is core cutter method, okay. So here it is generally used for soft soil and clay. It is not suitable for gravelly or sandy soil, okay. So as we need to push the core inside the soil, it is not possible for gravelly or sandy soils, right? Clear? So next method is our water displacement method. In this method, what happens? Generally used for cohesive soils. Cohesive soils is what? Like the soil in which water content is more, okay. Cohesive soil that are highly sticky in nature. Like clay soil is very preferable for this method, for water displacement method, okay. So in this method, we will take soil sample. As sticky soil we are taking, so we will combine a lots of soil and place into a proper shape. Like here we have given W1 a proper shape, okay. As it is sticky shape, so it can take any kind of shape, right? So first we take soil sample, that we will take the weight as W1. So in this method, sample of soil is streamed into more or less uniform shape, okay, and we will take that as W1. So next what will happen? So this W1 we can do paraffin wax. We will make it, cover it with paraffin wax, okay. So after covering the soil with paraffin wax, we will take the weight as W2. Now what? Weight of soil as W1, weight of soil plus paraffin wax is W2, okay. So why we just do this paraffin wax coating? Because when we put this soil inside one filled with water filled container, so this water cannot harm the soil, okay. So that's why we cover the soil with paraffin wax, right? And next what? The volume of soil plus wax. What happened? We will do this soil with paraffin wax coated soil. We will put inside one container, that will be that should be filled with water properly. Okay, after putting the soil with paraffin wax coated soil, what happens? There will be some discharge of water. Okay, so this discharge of water we will take as VW. Next is here. So we have W1, W2 and VW. The discharge of water is VW. Right. So what it says that the coated specimen soil is immersed slowly in container. Yeah. That is completely filled with water. The volume of water displaced by coated specimen is VW. Right. So we need to calculate volume of paraffin wax. No. What? To calculate gamma, we need W and V. So to calculate V, we need what? W and gamma. So to calculate what? Volume of paraffin wax. To calculate volume of paraffin wax, we need weight of paraffin wax upon gamma of paraffin wax. Okay. So this weight of paraffin wax we will get how? Like here, W1 is your weight of soil, W2 is your weight of soil plus paraffin wax. So if we subtract W2 minus W1, so we will get WPX, right? Here upon gamma PW. So if we have specific gravity of paraffin wax, then we will calculate GPW into gamma W as gamma of paraffin wax. Okay, so by this way we have volume of paraffin wax. So VW is our volume of soil plus volume of paraffin wax. We know that. So volume of soil will be what? Volume of water minus volume of paraffin wax. Okay, so we have here volume of paraffin wax. VW is already we have. Okay, so VW minus W2 minus W1 upon gamma PW. Right. So we have here our volume of soil. As we know, for calculation of unit weight, we have weight of soil and volume of soil. By putting the values here, we can calculate unit weight of soil. Okay, here we have cleared our pore cutter method and water displacement method. Okay, these are very water displacement method is not very pure method. Okay, there will be some mistakes as there will be displacement of water, there will be some losses. Okay, so here this method is not perfect, but we can use to calculate the unit weight of water here. So in this class we have learned these two methods. One is pore cutter method and another one is your here pore cutter method and water displacement method. In our next class we will understand submerged mass density method and sand replacement method. Your sand replacement method is the most important method we will discuss in our next class. Thank you so much.